Thank you. That's a good segue for this. How do we clean pads? So, there's 3 different major materials for pads. There's foam pads. You can use a nylon bristle brush, which will clean pads okay. But the better way is compressed air with a blowgun. And you can blow material off that pad. And if you have the Tornador branded blowgun, that's even better. That's amazing for pad cleaning. The other pad material is wool. Now wool you can clean with a brush, but it's actually much, much better with compressed air. And those of you that are mobile guys and you don't want to carry around a huge compressor, you don't have to. You can get the small little compressor. If the only purpose you're having compressed air is to clean pads, all you need is a small compressor, because you're using a little burst of air to clean a pad and that's it. You're not actually running a tool. So compressed air is the best for wool. Now there's a difference for microfiber. What we're saying on cleaning microfiber is any other method, including pad brushes and bucket washes and all that stuff, you really need to use compressed air, because microfiber grabs and holds things, and the only way you're going to clean it properly is with compressed air. Did that answer your question?
Yes, sir.
Okay. That was free, by the way. You didn't pay for that one. Hey, who bought tickets here to come to this event? Anybody? Did you buy? You didn't buy a ticket? Okay, so here's my promise guarantee. I'm going to make sure that you get exactly what you paid for today. All right. Oh, question in the back.
What about the spiked wheel pad cleaner? How does that work?
Oh, that's called a pad spur.
Yeah, pad spur.
So that is another version of using a brush, but it is a brush that spins around. Those are okay with wool pads. They'll shred your foam pads. I don't use them anymore. They're kind of old school. Compressed air is better. Okay? Tornador, yeah, it's great. Yes, sir? Bucket. Okay, if you're using the bucket pad cleaning equipment, here's my suggestion. And is there any salespeople in here that sell that bucket? Nobody sells it? Okay, good. I would strongly recommend that in the bucket wash systems that you do not use a chemical. Only use water, and the cleanest water you have available to you. Because if you use a chemical, that equipment does not rinse that chemical out of your pad. And now you're leaving the chemical in your pad. Even if it's dry, it's still in there. And then the next time you wet it with compound or polish, you're using what's in the compound bottle, but also the chemical that's on your pad. So I'm not a fan of those. I know they want to sell you the pad cleaning stuff to put in the bucket wash. I'm recommending water only. And the fiber pads, like wool and microfiber, those bucket wash systems work pretty good. They're probably not as good for foam, but they work good with fiber pads. Good questions. Yeah, oh, another one.
When you use a compressed air, do you want to spin the pad at the same time you're hitting it with compressed air, or can you just take the pad off and just clean with compressed air?
Do you want the pad spinning? Is that
Yes.
the question? You don't need the pad spinning, but it helps with cleaning because it's more movement.
Okay, center.
Yeah. So your compressed air will go into the material and fly off the solids, but if it's spinning, it actually will fly away. And if you don't like the person that you work with, you always clean pads in their direction. It works great that way. Okay, number 8. Oh, another pad question.
I saw you do something on a show once.
That wasn't me. I have a stunt double.
Okay, so your stunt double. You could not get dust anywhere. It was crazy with Myrtle Beach pre-show. You did something with a box or something while you were cleaning. A box attached to a vacuum. Something that really cut the dust down.
Yeah.
What was
That was it was a box, and it was a vacuum cleaner hooked up to the box.
like a shop vac?
A shop vac, exactly, that's what it was. And then there was a grid inside the box, and we would run the pads on the grid with the vacuum on, and it would suck out the material. So I was hoping somebody would create a product and launch it, but it never happened. Yeah, oh, new patent. So we made it just to try and figure out, because the reality is if you're blowing compressed air on a pad, you're blowing the material off the pad, and then it's floating around your shop or your garage. Yeah. Oh, one tip on that. A horse trough that's about 6 inches deep with water. You blow your pad into the horse trough, and the water will capture the material and it won't be flying around the shop. That's another tip. All right, so number 8, best way to F up random orbital polishing survey says, skip your test spot. Who knows what a test spot is? Some of you. So, when you're polishing on paint, you are being faced with paint variables, meaning hard paint, soft paint, everything in between, heavy defects, light defects, wet paint, dry paint, old paint, new paint. There's lots of variables, okay? What a test spot does is you isolate the right combination of pad and liquid and tool to get the best performance on that particular car. Because if you do the same combination on every car every day, you will miss the mark half the time. You will not get best performance half the time because of variables. So why do we do a test spot? And again, we hired this really expensive model. So what you do is literally try a combination on a spot on the car. Where? Try to find the worst defects on the car, and that's a great place to do a test spot. So the test spot will help you determine how the paint responds. It will help you determine which compound, which pad, and it will also define the tool and the procedure and the process. So a test spot is very, very important. If you want to mess things up, skip the test spot on every car, and literally you will not get peak performance on half of the cars you do. So this is super important. So one recommendation on a test spot is in the Rupes line, it's our yellow capped liquid with the yellow colored pad. Do the test spot with that. If you need something more aggressive, we have several levels above that. If you need something less aggressive, we have levels below that. So the yellow combo, good test spot. All right. Number 7, best way to F up random orbital paint or polishing is to use the maximum tool speed on the tool. Now we're Americans, so if there's 6 speed settings on the tool, we're looking for number 7 because we want fast. But I can tell you in the Rupes line, our tools are getting stronger and stronger every year. Our Mark III version is a very powerful tool. And if you use that on speed setting 6 all the time, you are stressing components, you're heating up the paint, you're heating up the pad. It is not meant to be used at max speed all the time. Speed 4. Speed 4 is your operating speed on our tools. Now at speed 4, you can reach your thumb over and adjust up or down as you need to based on the shape of the panel you're on, but speed 4 is it. You with me? There was a question somewhere? No. So again, if you run it on maximum speed all the time, you're going to have issues.
So when you're doing your test spot, you're running at 4?
Yes. You're priming on speed 2 for any of our tools, whether it's rotary, gear-driven, or random orbital. Speed 2 for priming. Speed 4 is your operating speed, and you do your test spot. The reason you do the test spot with speed 4 is because your test spot needs to represent what you hope you do on the whole car, which is going to be speed 4. All right? So I had some images I wanted to show you, but they're on another slide. Yes, sir?
If you open that door, there's more air coming in.
Oh, there is?
Get the cross breeze.
I don't know what you're talking about. I'm getting plenty of air. They're saying they get more air if we open this door, so we're going to leave this open. Is that better? It is hot in here. I don't know. I can't tell. I have a fan right here. All right, test spot. Max tool speed we did. Number 6. Best way to F up your random orbital polishing, fast arm speed. So how many of you use a rotary polisher? Some of you do. Now with that tool, you have to use fast arm speed, or what happens? You get too aggressive and you might burn through the paint. So a lot of folks have applied that technique to random orbitals, and here's the problem. Fast arm speed with a random orbital will get you poor results. So random orbital polishers, not just Rupes, but all of them, the slower you move the tool, the more work the pad does in that area. So you want slow arm speed. So 1 inch per second is kind of the recommendation, and you have to visualize what that is. Every second you move 1 inch. It's this fast. So that, I don't know about you, but it looks slow. And it is. And some people, when you first try this 1 inch per second, you're thinking to yourself, it's going to take me forever to get this car done. And it visually looks very slow. But the fact is that you are getting the job done faster. The slower you move the tool, you are getting more defects removed, you are finishing the paint better, so you're getting the work done faster if you move slow. So this is truly a system that you slow down to work faster. This is a hard concept for people to get, because all of us, we feel like if we're moving fast, we're getting the job done, but this is one example that that's not true. It's absolutely not true. You will get the car done better and faster if you slow down. Number 5, best way to F up your random orbital polishing is stuff your big tool in tight places. I'm talking about cars. I don't know where your mind went, but so actually this is very important because it's called edge work. Now this is a little fiat, but edge work is defined as outside 2 inches of every panel on every panel on the car. Raised body lines, curves and contours, A, B, and C pillars, headlights, mirror housings, painted door handles, and the small or tight areas. All of this is defined as edge work. And what we're proposing here at Rupes USA is that you do these areas on your car differently than probably you're used to doing. So you can do edge work with a full-size tool and a full-size pad, but this is definitely less effective and less efficient at doing all of this area with a full-size tool and a full-size pad. Can you do it? Sure. It can be done. But is it the best way to get peak performance? Is it the best way with low risk? No, the best way is with a smaller tool, a smaller pad diameter, have much more control in the edge work areas, and get them done faster. So what we're proposing is a 2-tool method for doing cars. Full-size tool, full-size pad for the flat areas, the mini and nanos for the edge work. Yes, sir?
What's your throw on the minis?
The mini, there's 2 of them. There's an electric and a pneumatic. The electric is a 12 millimeter. The pneumatic is a 15. They're both big orbit polishers. It just has a small pad. Yeah. Thanks for the questions, I appreciate it. Oh, another one.
On the pneumatic, does it have variable trigger speed? Where I know the electric is just one speed, right?
No, the electrics and the pneumatics are variable speed, but they do it differently. So the electric has a dial that you dial in the speed. The pneumatic has a speed paddle, so it's a paddle trigger, and you can go from 0 to fast based on how you push that paddle. Now I will tell you that the Rupes pneumatic 3-inch mini is the most powerful tool that we have. If you're going to burn paint with one of our tools, it's probably going to be with that tool. It is very powerful. We have them next door if you want to see that. All right, number 4. Number 4 is push down too hard. Some of us came from what I call the Porter cable revolution, where we went from rotaries to random orbitals, and we tried to get defect removal, but the only way with the 8mm orbit size is to push down. With large orbit tools, the orbit's doing the work, you don't need to push down that hard. A little bit of pressure, but not a lot. So my experience watching people use our own tools, our Bigfoot tools, is there's way too much pressure being pushed down on random orbital polishers. This is the kind of damage. When you push down with a Bigfoot random orbital tool, all the heat and stress goes to the backing plate. So you can actually ruin your backing plate, destroy your pads, simply by pushing down too hard. Now this is the outside edge where somebody did a combination of push down and tilt. Completely destroyed the edge. The edge is delaminating on the outside. This is an example of, you can't really see it with the picture, but this is actually material melting because it got so hot. Now this is nylon hook material, is specified at 240 degrees Fahrenheit as a melting point. So this melted and fused together the hook material. So somebody heated up this backing plate in an excess of 240 degrees Fahrenheit at the backing plate. Now this here you see, you can't see very well with this picture, but this is actually the opposite pad material on the pad has melted and bonded to the backing plate. These are examples of too much pressure, and I'm telling you, when you push down on our tools, on the random orbital tools, you just ramp up temperature, not on the paint. You don't feel it on the paint. It'll go straight to the pad, straight to the backing plate, and you'll stress components. So, enough pressure to compress the pad, but no more than 50% the thickness of the pad. So actually watch that with your eyes. No more than 50% the thickness of the pad, and that's plenty of pressure. Remember, it's a large orbit tool. The orbit is doing the work. So too much pressure increases pad load and decreases performance, damages pads, and could potentially damage the paint if you push too hard. You with me so far? Hey, has this been helpful? Okay. Question?
Yeah, isn't it true on some of the tools now they have sensors that will slow the machine down if there's too much pressure?
I'm aware of, in the programming in the speed module, I'm aware of programming where if there's pressure sensed, it will increase amperage to the tool, but I'm not aware of it slowing down pad movement. Yeah, if you get too much pressure, you'll stall the rotation, which, thank you very much, you just stole my next one here. So, too much rotation stall. Now what this means, let me explain what this means. There's a lot of discussion on the cyber interweb nets about pad stall, and there's a lot of people who misunderstand what this conversation is. So let me give you the straight poop on the pad stall. The tool generates two movements. There is a orbit and a rotation. That is what a dual action polisher does. Two movements, orbit, rotation. The orbit on this particular tool is gear driven and fixed. When you pull the trigger, you get the orbit. And with Rupes Bigfoot polishers, our large orbit is the workhorse. That is doing the work, the orbit. However, the rotation is random. So the rotation can stop and start and speed up and slow down. Some people think this is a problem with the tool, that it stalls. No, this is a safety feature that it stalls. This is your friend. This is why you're not damaging paint, because the rotation can stop and start and speed up and slow down. But the random rotation makes the tool truly random movement, which, by the way, every image you've seen of how a random orbital tool works, they're all wrong. Because you cannot possibly draw the movement of a random orbital tool because it's random. Anyway, back to rotation.
Question.
Oh,
If you turn your buffer on, will it free spin in a rotary action first?
no, it will orbit first.
It will, without putting any pressure on.
Yeah, in a free spin?
In a free spin.
Yeah. So there's two speeds that these tools do. There's no load and load. Load is when you put the pad to the paint, no load is spinning in the air. Now at a no load condition, when you pull the trigger, you get both the orbit and the rotation simultaneously, instantly.
Well, if you start it and say you're at your number 4, will it leave a rotary type scratch at first and then go to random? You know what I'm saying? If you take like a normal pneumatic tool, you start it, it's going in a rotary action
Right.
before you put pressure on it.
Right,
And if you do that, that's why I always tell you, start on, stop off type.
right, exactly.
Okay.
Yeah, and you want to do that with these tools, because if you start the tool up here in a no load condition, and as it's spinning, if you put it on the paint, you will experience both movements instantly, and you could make a mark.
Okay.
So what you said about putting the pad on first, turn the tool on, that's actually a better way to do it. Good question. All right, so the one point I want to make about this rotation stall, it's your friend, it's helping you. Don't panic, because momentary pad stall, like on a curve or a contour, totally okay, because the orbit is doing the work. So what do we need the rotation for? Two reasons. The rotation provides the randomness, which is important, and the rotation is your radiator. Have you ever tried to drive your car on the freeway without the radiator working? You won't get very far. So your rotation cools the paint, cools the pad, cools the backing plate, and that is the function of the rotation. So momentary pad stall, no problem. Just work that area with the orbit, and then move on to a flat area and pick up your rotation again. Cool? So if you're wondering what the proper rotation looks like, you make a mark on the backing plate. That is a good amount of pad rotation right there. That's the ideal. Most people operate this tool with too much pad rotation or not enough. This is the sweet spot right here. Cool? Yes. Rotation gear driven, that's not this tool. So this is a random rotation. The orbit's gear driven. So there's two movements, one of them is forced, one's unforced. Now we do have a polisher called the Melee gear driven, which has forced orbit, forced rotation both at the same time. Is that what you're thinking of? Okay. So this is the amount of rotation we're looking for to keep things cool, keep things random. Now remember, when you stall the rotation, you are taking a dual action polisher and turning it into a single action polisher. So you're not getting peak performance at that moment. All right, number 2, we are almost done. Number 2 best way to F up your random orbital polishing is use it like a rotary. So a lot of us came from the rotary generation where we learned polishing paint with a rotary, and then we switched to dual action random orbitals. But again, if you use the Bigfoot random orbital like a rotary, you will stress components and you will not get the best results. I'll show you what it looks like. No. So, how to make the random orbital not work? Tilt the pad, heavy pressure, and fast arm speed. It will make this polisher not work and you will not like the results. So definitely don't use this like a rotary. It takes a different technique. Well, yeah, you stall the rotation immediately. So, but you do get the orbit still. You do get the orbit still. All right, so it'll stop the rotation, but not the orbit. It'll still orbit, which means you're not getting peak performance. You're not cutting good. You're not finishing good. You guys want to see that again?
Yeah, yes.
There it is again. Now we're exaggerating a little bit, but I actually have seen people use the tool this way, and it's how you use a rotary. All right, so you ready for the number one best way to F up random orbital polishing? Don't use a Bigfoot polisher. You saw it coming, right? You knew I had to say this. Of course, I'm paid by the brand, so I'm going to say ours is better than theirs, but our Bigfoot random orbital polishes come in different shapes and sizes for different purposes. Some are edgework tools, some are flat panel tools, but that is the 13 best ways to F up your dual action random orbital polishing. If you want to see them all at once, this is all of them. If you were taking a picture, this is definitely the one to take. And again, I kind of use reverse psychology to teach you guys something, but hopefully you learned.
Sorry, guys.
This is the tips on how to get peak performance. Yep. So, how many of you learned something new today that you didn't know? Excellent. All right, you made me happy. Happy person. So, one last thing to do. And that is, we're going to pull a car in. I think they still gave me time, yeah. So what we're going to do now is I'm going to have a question and answer session. So if you have questions on random orbital polishing or anything Rupes, we'll answer those questions now. Then we're going to put the chairs away. We're going to pull a car in. And those of you that want specific coaching on the random orbital technique, then we're going to go do that on a car. Sound good? So any questions? Did anybody have any questions at all? Yes, sir.
The microfiber, you don't do the 6 when you prime it?
That's correct. And actually the Rupes recommendation on any fiber pad, which is not just microfiber, but now our new dual action wool pads. So any fiber pad, don't put 4 dots. That's not priming those pads. I was going to insert that in here, but I thought it was too much. But the fiber pads require different priming. You need to take some kind of a spreader and butter your bread. You're spreading the compound on all sides of the fiber, and that's how you get peak performance. Thank you for that. Yeah. Yes?
From that one, so every time you clean it through your microfiber, are you then priming it after?
So the question is with fiber pads, if you then blow it with compressed air, do you have to re-prime? Is that the question? Yeah. The answer is no. When you blow out a pad, you are evacuating the solids from the fiber. So the paint residue and compound residue. But I want you to try this next time you blow off a fiber pad. I want you to feel the pad, and it will still be moist because you have not blown off the moisture you've blown off the solids.
Each fiber is already.
It's grabbing and hold things and it has moisture. So you don't need to reprime the fiber pad every time you clean it. You add 1, maybe 2 pea-sized dots of compound and that's your reload amount. Good question. Actually, you know what? I have stuff to give away for good questions. I forgot to give them away earlier. There you go. You guys, you asked a good question over here. All right, any other questions?
They're gonna be good questions.
Now there's going to be all kinds of questions.
They're gonna be good, right?
Sunday, I'm getting it.
You have a question, sir? Yeah.
Is there any rule for lifting off the tool from the paint to get it slowed down or like, oh, we got paint time, it's fine?
Tell me again.
Any
Robert.
rules for lifting a DA off the paint?
Off the paint while it's running? Yeah, the rule is don't do that. Because as I said, there's 2 speed conditions. There's load at speed, which is on the paint, and no load in the air. Anytime you pull the tool away from the paint, you are stressing the pad, because this is a big orbit that it's doing, and you're stressing the pad when you do that. So the strategy is you turn the tool off the trigger and then pull it away from the paint. Make sense? There you go. Yeah.
What's your personal opinion on the washer mod?
Ah, there's always somebody who asks it. You asked my personal opinion. All right, I'm going to give you both answers on the washer mod thing. Does everybody know what we're talking about?
I didn't hear a question.
You know the washer mod? No. Washer mod is. I don't have. Oh, here, water. All right. So this tool. So this tool has a shroud that makes physical contact with the backing plate. This shroud touches this backing plate. The purpose of that friction point is no load condition, free spinning in the air, it slows down the pad. So it is important because without that friction point in a no load condition, it would destroy the pad because this is a violent movement on the pad. But as soon as I put the pad to paint, a load condition, the power of the motor exceeds the friction point between the shroud and the backing plate. So when the motor's on and you pull the trigger and you're actually polishing, it's as if that friction point doesn't exist. Because the power of the motor overpowers that friction. So the friction is for no load condition. In a load condition, the friction is neutered. Now here's, you asked my personal opinion. So I have the 2 answers. There's the Rupes company line answer. Am I on CNN right now?
Got it.
So the company line is that Rupes does not recommend any modification to the tool of any kind. We don't even recommend you change a cord to a different cord. So no washer mod, no changing the backing plate diameter, no modification at all. Because the tool gets peak performance as it's designed. That is the Rupes answer. Now the Jason Rose answer. Before I joined Rupes, every one of my Bigfoot tools had the washer mod on it. So read into that what you want. But I do believe we are on our 3rd version of the Bigfoot tool. We are on Mark 3 now. Mark 2 and Mark 3, I firmly believe, and this is my opinion, the washer mod has no or little value to the performance. Because the tool now has 30% more power to the pad than it used to have. We are actually telling people with the Mark III version to back off on your speed because it has too much power to the pad. Instead of speed setting 6, we're telling people use 4 because you have plenty of rotation now. Does that answer your question? Okay. Yes, sir. Oh, wait. I'll give you these, but they do not have the washer mount applied. There was another. Yes.
So if you're using an LHR Mark II, is speed 4 still your sweet spot?
Yes, because from the Mark II on to Mark III, the tool has 30% more power than Mark I.
So 2 and 3 have the same amount of power?
They do, however, I'm glad you asked this. So I'll give you these now. So the difference between Mark II, Mark III. Mark II, we put 30% more power in the motor, so every speed setting had 30% more power than the previous version. It's much more powerful. What we did in Mark III, now this is our Mark III version. What we did is remapped the speed module to put more power in speed settings 2, 3, and 4. So we actually took orbits per minute from the high and the low end and put more power in 2, 3, and 4. So if you want the sweet spot on power for that tool, it's in there. The choice of a pad material is going to be dictated by the paint and the defects. The harder the paint, the more defects, the more you're going to go with wool.
Is one faster than the other?
Wool would be faster. And if you have not tried the Rupes DA wool pads, I strongly encourage you, because we hit it out of the park on performance. This is amazing performance. Some of you like microfiber, so our wool pads are actually microfiber-like cut, but they finish like foam. It's amazing. And if you get one pad, get the Rupes yellow wool pad. Absolutely phenomenal. It cuts like wool, finishes like foam. It's crazy good. Here you go. Yep, another question way back there. So the question is, if we use rotary over the Bigfoot random orbital, what's the question? Oh. Are you a dinosaur? I don't know. Is it a bad thing to do? No. But you are, I'll tell you what you are doing is you're taking old technology, which is the rotary. So rotary came about polishing cars in the 1950s. It was a right angle grinder that was repurposed for polishing paint. And that rotary movement has not changed till today. So here we are in 2019, and the same exact rotary tool is like it was in 1950. So it is old technology. The large orbit random orbitals is newer technology. There's a place for both, I believe, but more and more the random orbitals are all you need for the most part. Wait, I want to give you one. I'm going to hand those back to that gentleman. Watch your head. There's one. Almost. Yes, sir.
When you said to change the pad to every other panel, does that apply to the pads? When I'm using the other pads, it looks like it has after like going into a section of passes, it just looks like it has. So am I supposed to change that?
No, but you're supposed to clean that. So here's a good point. I'm glad you asked that, because fiber pads, have you noticed that after 2 applications, the fibers lay down and go flat?
Yes.
This is a big misunderstanding, especially with microfiber. When the fiber lays down and goes flat, that is not a bad thing. All that means is that the fiber has oriented itself to the movement of the tool. This is a good thing. So when it lays down, don't think like it's a bad thing and you have to clean and blow it and fluff it up. Because look at this. So fibers that are sticking up like this, fibers that are laying down, which has more surface area? Laying down. So your fiber is actually doing more work for you when it's laying down. So when it orients to the tool, that's a sweet spot. You don't have to. Now when you do need to clean it is when the fibers are laying down, but now you have this shiny glaze, compound glaze look to it. If you have shiny flat, like you barely see the definition of the fibers, that you need to blow and fluff up and clean. Oh, the question was what air compressor to run the air tools. The air tools, they require 90 psi, but the more important specification is 12 to 14 CFM. Now CFM, cubic feet per minute, is a unit of measure for the volume of air, not the pressure behind the air, how much air. So you need that much volume to run the air tools. And it's not a small air
I do
compressor.
mobile and I have to figure that out.
Figure 3 CFM per 1 horsepower of a compressor.
Yeah, there we go. So 3 CFM per horsepower. Yes, sir.
Yeah, what are the key differences between a pneumatic and an electric driven? Why did you choose one or the other?
If you have a big compressor. Now, naturally, the choice of whether to use electric or pneumatic, you have to think through the compressor side of it. It's an expense, it's a size, and you have to have that to get performance on the pneumatic tools. But the reason that you would choose pneumatic tools, smaller, lighter, more ergonomic, sometimes more powerful. Our Mini, the LHR 75, is more power than any electric tool we have. But it's smaller, lighter, easier to use. Oh, and lower maintenance. The tools,
Easier to repair too.
yeah, easy to work on, less moving parts, lower maintenance. There's a definite plus side to pneumatics. Yes,
I have a
sir.
question.
Oh,
Questions? Hey, brother, after color sanding with 3000, what's your favorite combo to correct the sanding marks?
so the question is, after 3000 grit sanding mark, what's the favorite combo for polishing it out?
What's more effective and easy?
Me personally?
Yes.
Okay, so I'm a short cycle compound guy, so I picked our short cycle compound, which is our Zephyr with the blue cap. But I use our yellow wool, our new DA yellow wool, with the blue Zephyr. And the paint will dictate if it's a one-step or not. Sometimes we can go from 3000 grit to complete wax ready done in one step. But it's paint dependent. So sometimes you can do that, and then you need a second step. So we switch to our yellow combo, which is the yellow foam pad, the yellow capped ceramic, we call it. And then that's your second step. That's my go-to. Did I give you one? And back, in the back of the room there.
Can I use the pads and polishes on another type of machine, other than press machine?
Okay, the question was, can you use Rupes compounds and pads on other machines? It will self-destruct in 5 seconds. I don't make the rules, we just follow them. No, the answer is yes, you can. In fact, our Miele branded compound and pads, that will make any other gear-driven orbital run better. Is there anybody from Flex here? Or just, okay, good. Yeah.
Personal preference question.
Yeah?
If you had to choose one or the other for versatility, would you choose
Hang on a second. Hang on a second. I'm right-handed, but I'll try left-handed. There you go. So, question. Okay, this is a question we get a lot actually. The question was, between the option of the Rupes Mini or the Rupes Nano, which would you choose? So, I have to ask you, what are the other tools you have? Do you have the full size? Standard 8 millimeter? So it's standard D8. Oh, you have one tool. So I would say a good second tool, so you already have a full-size random orbital. This good second tool is the Mini. Get the Mini. The Nano is only if you happen to do a lot of edge work at a high standard of excellence, a high standard of quality. The Nano can help you because it's very precise on edges.
Around mirrors, I love around mirrors.
Mini can do all that stuff. Yep.
You have one over here?
Oh yeah, and if you have lots of money, they just get both of them.
That. I would be asking a question.
But actually, next door, if you like, you can actually try both the Mini and the Nano. Try them and actually make your own choice. Yes, sir. So the question is 15 or 21. So here's the thing, if this is the first Rupes Bigfoot tool you buy, that would be my choice, the 15. And the reason is because it has a smaller pad diameter, you can get into curves and contours, but it's a false conclusion, and hear me on this, it's a false conclusion if you believe that the 15 millimeter and the 21 millimeter perform differently in terms of defect removal. So a lot of people think bigger is better, so the 21 must be better, right? Did anybody think that? Nobody's willing to admit that you thought that.
I think that.
You did think that.
I still think that.
You still think that.
Prove me wrong.
I will. I'm going to go to your shop. So the 15 and the 21, and by the way, you got to define what we mean by aggressiveness. Because the 21 millimeter tool, which is up there on display, has a bigger pad diameter. So of course, it's got more surface area. It's going to remove more defects. Bigger pad. But because of the orbit size, doesn't make it more aggressive. So here's what the engineers did. I'm giving you more answer than you had in your question, but this is no charge. You get this for free. So the engineers made two tools, 15 millimeter and a 21. Believe it or not, they both are fully intended to do paint defect removal at the same rate, but they come at it different ways. The 21 millimeter Bigfoot, big pad, big orbit, slower motor. The 15 millimeter, smaller diameter, smaller orbit, faster motor. But if you do put them side by side, they will both remove defects at the same rate of defect removal. But the bigger pad wins because you got more surface area. So that's how that works. Oh wait, which one do you have? Huh?
I have the yellow one.
You have the yellow one. Okay, here you go. Thanks for your questions. These are awesome. Yes.
Okay, a lot of my detail buddies, they'll get the 21, but they want to change out to the 5-inch backing plate. Why?
Yeah.
Can I ask why?
So this is a great question. The question was that he asked, I'm going to get by you here. We buy this 21 millimeter tool with the large 7-inch pad diameter, and we change that backing plate to the 5-inch. Okay. Now we're Americans, and we know more than the engineers do, right? So we're going to modify our stuff. But let me tell you what you're actually doing. If you take this 5-inch backing plate, put it on the 21 millimeter tool, you are actually dumbing down the movement of the tool. So some people think they're getting more power, but you're actually slowing down the movement of that tool with that smaller backing plate. Now our company line is no mods, no modifications to the tool of any kind, including that one. But it's a false conclusion that people think, oh, I like the 5-inch pad for contouring and getting into curves and contours, but the 21's more powerful, so I'm going to take the 5-inch backing plate, put it on the 21, and then I've got everything I want. The reality is you just dummied down your tool.
What about the 21 on the 5? Or I'm sorry, on the 15?
So you take the bigger backing plate.
Bigger backing plate on the 15.
I have not heard people do that. Has anybody done that? You're not willing to admit, of course. But let me think about what you're doing there. So the bigger pad diameter on any random orbital tool, not just Rupes, but any random orbital tool, the bigger the backing plate, the slower the movement of the tool, because you have more surface area on the paint and you're slowing the randomness of the tool down. So to answer your question, you just dummied down your 15 millimeter tool.
The other thing is that on random orbital sanders, the backup pads are weighted to the bearing that's inside there that's creating your random orbit. You change the pad, you create more weight or less weight, create more vibration in the bearing, you void the warranty.
Yeah.
Well, in our product line, you don't void the warranty with that, but you are doing exactly what you say. So it is weight mated. So inside here, getting technical on what you're saying, inside here, there is a counterweight assembly. So as the backing plate and pad, so the backing plate and pad is swinging around on this side, right? Inside the tool, there's an equal weight on this side. So it goes like this. That is what the tool is doing, is like this. And it's actually, with our product line, it's a 5 gram swing of the pad weight that if you put on a 5 gram difference in pad, you're going to throw off the balancing of the tool. Yeah.
Got a question?
Another question.
Regarding warranty and actually repair. Warranty, what's your manufacturer's warranty on the electric tool? Is it the same as the pneumatic tools?
Yes, actually all of our polishers, whether it's pneumatic or electric, 1 year warranty.
Manufacturer's defect?
Yep.
Question on the repair. Where do you send it for the repair? What authorized repair houses do that?
So some of our distributors do repair on our tools, but Rupes USA in Denver, we have the strongest repair program in the industry. So it works like this. Within warranty, if you bought a tool and it's within the year of your purchase, go to our website, rupesusa.com. There is a tool repair form, name, address, phone number, what happened to the tool. You will get emailed a FedEx shipping tag. You throw the tool in the box, send it to us. 3 days later, we send it back to you. And we pay the shipping both ways. Now that is within warranty. Now post-warranty, go to rupesusa.com, fill out the repair form. You will get a shipping tag. You ship the tool. We have what's called a flat rate repair program. So some of our customers, 5-6 years later, you've used the tool every day. It's well used, and you can send us that tool, and for $95, we will completely refurbish that tool. So you'll get back a tool that's like new for $95.
Even if it's beyond type repair, have you ever had an instance where it's just guys destroy the tool type of scenario?
We get tools in that look like they've been run over by trucks and stuff. But here's the limits on the repair program. So there's 3 parts to this tool: the head of the tool, the midsection, and then the handle and trigger. So this midsection, the mid housing, has the motor and the armature. If those are destroyed, it's not included in the $95. We'll still repair it, but we're gonna charge you for a motor. But everything else is all covered in the flat rate. So I mean, it literally could look terrible, and we'll replace everything.
Does that warranty transfer if you sell your tool to somebody?
So you bought it and like 6 months later you sold it?
Well, say you have a Mark II, you want to upgrade to a Mark III, you sell the Mark II because you don't want the Mark II anymore. Someone has an issue with the Mark II a year, whatever down the road, will it still be covered under warranty for that $95?
Yeah. Now sometimes we ask for proof of purchase, so if you have that, then it's covered under warranty whether you were the original owner or not.
Okay.
Yeah. You just have to have proof of purchase. Yeah. These are great questions. Barry McGuire.
I have a question.
Okay.
Why do you always have the best answer for every question?
Because I had a good teacher. Is that a great answer or what?
There's nobody in the industry that I respect more than Jason.
Oh, thank you, Barry.
Possibly you're all hearing that. For a guy that goes backwards about 30 years, 25 years, I don't know.
Thank you so much, Barry. I'll pay you later. But no, since you're being nice to me, no, I do want to say something truthfully about this gentleman. So I would not be standing here helping you with information if it wasn't for Barry McGuire 25 years ago taking a chance on a guy that was just wiping on cars, right?
Well, you do what you're doing without any training. You had the instinct, right? You just had it. And it was Nicole.
Yeah. She talked you into it.
Well, we both do, but she said, we've got to get Jason to get it.
Yeah.
I remember that so clearly. And you hit the ground running, you know.
But I literally would not be here if it wasn't for the McGuire family. So anyway, I want everybody to give a round of applause to Barry.